Civil Engineering Lab. I'm educating with Ikofi and I'm a technical officer here. Today we are going to look at how rapid chloride permeability test can be conducted on concrete samples. Soon after the hydration of cement, a protective layer is formed which adheres to the surface of steel rebars. However, the chloride ions, when they penetrate into concrete, they destroy this protective layer which is formed on the steel rebars. And when this layer is no more there, what happens is in the presence of water and oxygen, corrosion of these rebars occurs, which can cause cracking in concrete. So it is very, very important that we conduct this test on concrete samples so that we know how our concrete will behave when there is chloride attack. So we have some samples prepared in the laboratory which we are going to use to conduct this test. First and foremost, before you conduct the test, you need to saturate your sample, and in doing that you saturate it for a dry period of 3 hours, a wet period of 1 hour, and then a static period of 18 hours. We have an intelligent concrete saturation machine which we use in saturating the concrete samples. This is the intelligent vacuum saturation machine, and as you can see, it's automatic. It works on its own. So once the test starts, for the 3-hour period of the dry vacuum, it runs. There is an inlet which will allow water into the chamber, and then it will switch to the wet vacuum saturation. From then it will move to the static saturation, and then it will stay there for 18 hours. So as I said earlier on, the saturation takes place for 22 hours. And then yesterday we started this, and the samples are ready for the test to be conducted. So I will just first release the pressure that is built up in the chamber. Then I will drain the water out of the chamber. And you can see our samples in the water. So these are the samples I took from the vacuum saturator, and the diameter of the sample is 100 mm and the thickness is 50 mm. So we are going to arrange these samples in the applied voltage cells and then conduct the test on it. So now we are done fixing our samples in the applied voltage cells, and the test is going to be conducted in accordance with ASTM C1202. From the code, we are supposed to connect the negative terminal of the cell to 3% sodium chloride solution, and then the positive terminal of the cell to 0.3 molar solution of sodium hydroxide. So now I'm going to switch the cells on here and operate the machine from this PC. We have a software which we are going to use to operate the machine. But then we have to make sure that the voltage that is passing through the current is 60 volts. So I'm going to adjust this voltage here to the 60. Then I start my reading here. So now we start the test from the machine, and as you can see, the software has started picking data from the machine here. So the test is going to last for 6 hours, and then it's going to take readings, current readings at 30 minutes interval up to the 6 hours. So from then, the total charge that will pass through each specimen is going to be determined, and from the standard, the amount of current that the charge that passed through the sample is going to be used to determine the chloride ion penetrability of the sample. If the total charge that passed through the sample is high, it means that chloride ion penetrability is also high, and that the sample is not that resistive to chloride ion. Thank you.